This is Saxon Advanced Math 104.B, and these are geometric series. Now, in the same way that we had in the previous, and if you didn't watch 104A, you need to watch that lesson to understand the difference between a series and a sequence. And we're going to develop a formula for this. And you'll stay with me as we get into the weeds just for a moment, and we come back out of them. I think that you'll understand this. If we understand that we have a first term, right, and a second term, and a third term, and they have a common ratio, and that common ratio is so the first term doesn't have a common ratio in it. It's r to the 0 because it's just 1. But the common ratio is how much it's going up. And remember the difference between geometric and arithmetic. Arithmetic has a common difference. It's being added to it each time, whereas a common ratio means it's being multiplied by that common ratio each time. So the first term it doesn't have a common ratio in it, right? The second term has the common ratio raised to 1. The third term raised to 2. So remember that the formula we were using was a1 times r to the n minus 1 would give us that ratio. But what if we wanted to go to the second to last term, right? What if I wanted to talk about this one? Well, this one would be the number of terms minus 1, which means this is one less, or minus 2, okay? And just hold that in your head just for a moment. It's minus 1, which is minus 2. A series in geometric would be a to the 1 r0 plus a to the 1 r2, r1 plus a to the 1 r2, a1 r3, and so we would go on, and really what we're saying is the second to the last term is a1 r to the rn minus 2, and the last term is a1 rn minus 1. Now, what if we went ahead and said, I want to multiply both sides of this by an r? Well, I would have to distribute that r, the common ratio, but I would get r Sn equals AR1, because this would be 1 plus 0. This would be 1 plus, 1, which is 2, 3, 4. Notice it would do the same thing, except the very last, second to last term would become an n minus 1, because I have one more r in there. And this one would become just the n, because I have one more r in there as well. So this would be, now what if I took these two and I just subtracted them? Now I'm working with an unknown number of terms, but I know that these number of terms exist, right? I don't know, it doesn't have to be there for this formula. And when I do so, I would really say a1r0 just as a1, but the a1r1 would cancel this one, this would cancel this one, this would cancel this one, and so on, right? The next one I didn't write here with the 4 would cancel the 4, and so on as I subtracted that out, except for when we get to the end here, right? And that would give me, the n minus 1 would cancel out that one, but I would be left with an a1rn, where it had nothing to cancel it out of. Okay? So these two would be left, my first and my last term as I subtracted, and then I would say Sn minus Rsn, right? Sn minus Rsn. So I just subtracted this one out of the first term. And I know that was confusing, but we're deriving a formula here. We're getting to somewhere. And I look at this and I say, well, both these have an Sn in them. Let me pull that out to the front. So I factor that out to the front. On this one here, I say both of them have a1 in it, so I pull that a1 out. Okay, now I have an Sn, 1 minus r, and a1 times 1 minus r to the n. But what if I went ahead and said, let's look at this. I want Sn, I want the sum of the series, right? I'm going to go ahead and divide both sides by 1 minus r, and that's going to give me a discrete formula that doesn't have an unknown set in it and allows me to come up with exactly what it would be, the sum of all the terms in the geometric series. So it would be equal to the first term multiplied by 1 minus the common ratio brought to the nth power, right? The nth power being what the value of the number of terms that I'm looking at, right? Which term number I'm looking for, divided by 1 minus r. Now, example 104.2, and let's look at how they want us to do this. Develop the formula for the sum of the first n terms in a geometric series, and use the formula to find the sum of the first 9 terms in a geometric series whose first term is -8 and whose common ratio is -2. Now, let's go ahead and work with this. Step 1 would be literally do this again. And there's a reason why they're doing it. They want you to be familiar with doing those steps. So yes, I realize that all of you, including myself, would pull the book open and go back and copy this down again. And that's fine. That's all they're looking for you to do, at least in the homework. Now, of course, on testing or other assessments, they want you to memorize those stuff. But if you do these a couple of times in homework, you'll get to the point where that's just second nature anyway. So that's step one. Step two says, let's use that. So I have my formula. And notice all I've done is rewritten my formula from here up to there. Now, I'm going to take that and I start labeling what I know. Well, they told me in this, the sum of the first 9 terms. So the number of terms in is 9. In the geometric series whose first term is -8, first term, that's A1. I write that down. Then I say, in whose common ratio is -2. Well, my common ratio is my R variable, R equals -2. This is a very important step, and the book doesn't always show that step, but I'm going through and labeling what the problem tells me. Okay? Therefore, when I get to this and I say, I want the sum of the series in geometric series of this in the 9th term, I can plug in a 9 right there for n, right? A1, I'm going to plug in a -8. R, I'm going to plug in a -2. N, I'm going to plug in a 9, right? 1 minus a -2. Y, that's my R. Then I just start simplifying. Now, I want you to pay attention to the simplification steps here because the order of operations you choose to use, if you don't follow them, you'll want to multiply first instead of using your exponents or your parentheses, and it will mess you up. So I'm going to take this -2 to the 9th power. Okay? When I do so, it gives me a -512, but I have a negative in front, so that is a positive 512. So I have 1 plus 512 times -8. 1 plus a -2, or 1 minus a -2 is 1 plus 2, which is 3. So then I multiply this out, -4104 over 3 is -1368. There I have found the sum of the geometric series. Now, geometric series are a lot more difficult to do in your head. Well, I showed you how you could do that with arithmetic series. Not so easy with the geometric series. Look at example 104.3, and I went ahead and put this up here, even though I usually don't view the second example, because I want you to see how simple this is. This just says find the sum of the first 10 terms in the preceding example. Well, I'm already set. I have this, but I'm going to change all of the 9s into 10s. That's all I did. The 9th becomes the 10th term. Then I simplify and I get 2728. It's that simple. If you will go through, look at how these steps worked out. Now they multiply by -1 and add it instead of subtracting. That's the same thing. But if you'll go through and understand those steps, walk through it step by step, write it out as they do it. Don't just read the book or don't just watch me do these. You'll need to actually put them on paper. There is a cognitive learning cycle that makes it so that you'll remember this much more readily if you will take the time to go through these steps. Write this example out because this is a little bit more in-depth of an example than the A lesson. You'll want to go through and do that so that it sticks in your head. Oh, this is the formula, so you're not just memorizing another random formula that is going to be gone. You know how to rederive that formula.